So believe it or not, we've done all that work and we still have not gotten to our dynamic programming step. But we have started with the foundation. So one thing you want to make sure you're doing is when you're starting off with dynamic programming is not to try and go straight to the optimized dynamic programming solution. I know that's the mistake that I made. You want to go in the order that will help you build towards the dynamic solution. So that would be to start with your recurrent problem. So using recursion, seeing the relationship, building the recursion tree. And then from there, you want to look for what are called overlapping subproblems. So you'll notice here we started with 4, then we called fib of 2, and we got an answer of 1 for fib of 2. And then we went here, and when we called fib of 3, we ended up calling fib of 2 all over again and got an answer of 1 again. Same answer as here. And so instead of doing all the work here and then coming over here and doing all the work all over again, it would make sense just to do the work once, save it, then when we come across the same problem again, just to look it up in a table and then use it again. And it may, since this problem is pretty small, you may not notice the benefits of it. But if we were to go to, say, 10, you'd see multiple instances where we're repeating the same steps over and over and over again. And so it definitely helps to take a problem that otherwise would be exponential and turning it into something that can be done typically in linear time or in squared time. So we'll start by modifying the code we originally wrote, and we're adding an array which we're going to call memo. So this step would be to take our original recurrent solution and transfer it into what is called a memoization. And so I'm going to add an array here. And I'm using integer instead of int this time. That way, if a value is not saved, it'll be equal to null. And so I'll know that I have not added that value to the array yet. So an integer array called memo. And then I am going to add another method here, which is going to basically call the fib method and also initialize the memo array. And it's going to take an n, which is what's going to be passed into fib. Okay, so the first thing I'm going to do is just check the value of n, make sure it's valid. And just returning 0 if it's invalid here. You may also want to return -1 if you prefer. And then I'm going to do this check up here. So if n is 0, it's just going to return 0. If n is 1, it's going to return 1. So when we come to this line, we know that n is at least 2. So I'm going to initialize the memo array. And I want memo to start at 0, but I want it to go all the way up to n. So the size actually needs to be n plus 1. And then the very first thing you do with memoization and with dynamic programming is everything you know already without doing any work. You save those values in your array or your matrix, whatever you're using. So in this array, I am going to store the values I know already, which are memo 0, that's 0, and memo 1, which is 1. Finally, I'm going to call my fib method now. And the value is what I'm going to return. Okay, so this is just the setup here, just setting things up. So then we come here and we're going to check to see if this value has been found already. So if memo sub n is not equal to null. So remember, if we haven't set the value yet, it will be null. So far in the very beginning, we've only set 0 and 1, but there are n plus 1 elements. So the elements 0 and 1 are set, and all the rest are null in the very beginning. But if we come across any element that is already in our array, we are going to return it. Otherwise, we are going to do the same thing we did before, except here we're going to save our answer in memo sub n. And at the end, we are going to return memo sub n. So it's essentially doing the exact same thing we just did, except memorizing the values. After we calculate a value, we store it. And then if we ever come across that value again that's been stored, we return the stored value. Okay, now we've made it to our final step, which is to convert this problem into a dynamic programming problem. So the very first step is to initialize your array or your matrix that you're going to use, and to initialize what you know without doing any work. Which values can you fill in already? Okay, the next step and we're not going to be doing this anymore, would be to create a for loop that goes through all the possibilities. And I'm going to start this loop at 2 because I know what memo sub 2 is and I know what memo sub 1 is. So the next one that I need to figure out would be 2. And I can figure out 2 by simply knowing 0 and 1. So this step might be a little bit confusing because before we kind of went backwards. We started at 4 and we worked our way down to 1 and 0 and then worked our way back up. But here we're actually kind of going from the beginning all over again. Instead of working backwards, we're working forwards again. So we're starting at 2. And we're going to go to the end of memo. And we are going to set memo sub I equal to memo sub I minus 2 plus memo sub I minus 1. And if we start at 2, then that means I minus 2 would be 0, which we have here, and I minus 1 would be 1, which we have here. So this would be basically starting out at 0 plus 1 and saving memo sub 2 as 0 plus 1, which is 1. And now when we go to the next value that we need, which would be 3, it's going to then have the previous 2 values already stored in memo for use for the next increment of I. So each increment of I is guaranteed to have these previous values already stored in the memo array. And it's going to get all the way to the end. And at the end, this will be equal to memo sub n. And it's going to store the value in memo sub n. And then we just simply return memo sub n. So this basically takes away the need for recursion. And so what you're saving here has the same runtime as before. It's just not using the call stack. And so you're saving space on the call stack here. But as far as the length of time this would take, it's equivalent to the memoization method. And one thing you should also notice is we are not calling our fib method here. This is all we need is the for loop kind of replaces the recursive call. And that's it. And so those are the steps for going through a dynamic programming problem. First is to come up with a recurrent relationship. From there, you use memoization to help to identify subproblems and save them for use when we come across them again. And then finally, you can get rid of the recursion completely and just use a for loop and store the values that you know already inside of your memo. And typically use either an array or a matrix to save these values. Okay, so hopefully this tutorial is helpful for you in getting started. Again, I explain all the details. So hopefully I didn't go too slow for you, but hopefully I did help anybody who could have been struggling with this topic. I'm going to add some more tutorials. So this is just kind of the beginning. I went over every single detail to make sure you get a full, thorough understanding of everything involved in dynamic programming. And so once you get a strong foundation, then I think that's when you can move a little faster and go through it. But first step is to build that strong foundation and to understand every single detail before you start skipping here and skipping there. So that's it.